So this one, we have a product rule scenario. So I'm going to do the first derivative is the first function times the derivative of the second function. Remember the chain rule, the derivative e to the negative x is e to the negative x times negative 1. And then add on the first function, which is 1 times the derivative, or sorry, derivative of the first function, which is 1 times the second function. All right, now we set that equal to 0, and it might help to factor it. So I'm going to take out an e to the negative x. That's going to leave me with negative x plus 1. Now, e to the negative x will never equal 0 because the exponential function never actually equals 0. So that will never equal to 0. But this will equal 0 when x equals 1. So therefore, our only critical number is 1. So that makes our sign chart pretty easy. So I pick a really big negative number. And again, if you think about what e to the negative x looks like, that's just the exponential graph that is reflected. So it's going to look like that basically, except for not crossing the axis at all, just kind of going like that. So we know that it's always positive. So we don't even need to worry ourselves about that because we know this will always be positive. So we just need to figure out where this part's going to be negative. So if you have a big negative number, you'll have a negative times a negative. So a negative times a negative, let's say 50, right? Plus 1, and you can see that'll end up being a positive number. Whereas if x is a really large number, like 700, you have negative 700 plus 1, which is negative. So you can tell on this one that your critical number is x equals 1. And we can determine if it's a local max because our derivative goes from increasing to decreasing, so that, sorry, our function goes from increasing to decreasing, which means that at 1, it would have to be a max. So it's a local max. All right, we can use our sign chart to determine whether we're increasing or decreasing. Remember, if your function's derivative is positive, that means your function is increasing. So I'm increasing from negative infinity to 1. My function is decreasing wherever my first derivative is negative, so from 1 to infinity. And now let's look at concavity. So concavity deals with the second derivative. So we're going to have to do the second derivative. Our first derivative was e to the negative x minus x e to the negative x. So our second derivative will be the derivative of e to the negative x, which is e to the negative x times a negative 1. And then we're going to have to use the product rule over here. I'm going to use parentheses so I don't forget to distribute that negative. So I have the first function times the derivative of the second function, e to the negative x times negative 1, and then add on the derivative of the first function times the second function. All right, we're going to set this equal to 0. Might be helpful to factor out or distribute that negative. So second derivative is equal to negative e to the negative x minus a negative, so that's going to be positive, minus e to the negative x. Factor out that e to the negative x, I'll be left with negative 1 plus x minus 1. As we established, e to the negative x never equals 0, so I don't even need to worry about it, and I'm just concerned about x minus 2. Well, I know that's going to equal 0 if x is 2. So therefore, x is 2 is a possible inflection point. However, we're not guaranteed it's an inflection point. We have to make sure that the second derivative actually switches signs. So I go and I do a sign chart. So I put 2 there. I pick a number less than 2, so negative 30,000. Right? Negative 30,000 minus 2 is negative. If I pick another number bigger than 2, 50 minus 2 is positive. Okay, so we do know that it's an inflection point because our second derivative switches signs. All right. And then with our sign chart, it's really nice because now you have the work there. So you can say, okay, my function is concave down wherever my second derivative is negative, and that happens from negative infinity to positive 2. And my function is concave up from 2 off to infinity. All right, so let's hope that that helps you get a start on today's homework. And I will be here to answer any questions you have tomorrow. Have a good day.